Hey everyone, I'm out here in the garage, and what we're going to be doing today is taking a look at the 2004 Honda Pilot's front brakes. So stay tuned. So if you're new to the channel, just want to welcome you here, and hopefully you'll consider subscribing if you like what you see. Also, check out Car Apprentice on Instagram, Twitter, and Facebook. I post lots of pictures and videos on those platforms before I post anything on YouTube. And occasionally I'll post things on those platforms I don't post on YouTube. Also, check out the website at carapprentice.com. And don't forget to hit the like button if you like this video. So what we're going to be doing today is taking a look at the front brakes on the 2004 Honda Pilot. So I'm just kind of going around the car and checking things to make sure things are in working order. And this is one area that is typical when you buy a car, that you're going to have to do some sort of work on the brakes to get them totally functional and make sure your car is safe on the road. So we're going to do a little bit of analysis on the front brakes, and another thing I'm going to introduce in this video is the Kwik-Way on-car brake lathe. So let's get into it. Alright, so I have the car on jack stands in the front, and I'm assessing the condition of the brake pads and rotors to decide my next steps. The pads are obviously low and need to be replaced, but it appears that the rotors are in decent shape. During this video, I'm going to be flipping back and forth between the driver's side and the passenger side at times to show different aspects of the process. To get a closer look, I decided to remove the brake calipers and caliper brackets from each side. I'm just showing the passenger side here. First, I removed the two brake caliper bolts with a 12mm socket and hung it from the strut with a bungee. You can also use S-hooks. Next, I remove the brake pads. At this point, we can start taking some measurements of the rotor, but I'm going to remove the caliper bracket so you can see a little bit better. The caliper bracket bolts get loosened with a 17mm socket on a breaker bar, then they're removed. Alright, I'm going to check the rotor's thickness to see if they can possibly be turned. Basically, turning a rotor means removing some of the material until the rotor is nice and flat for the new brake pads. The measurement should be taken at 8 spots around the rotor at 10mm from the edge. So I use a set of digital calipers, since I don't have a micrometer. A new rotor's thickness is 27.9 to 28.1mm, or 1.1 to 1.11 inches. The service limit, which is the minimum thickness allowed, is 26mm, or 1.02 inches. Here are this rotor's measurements. As you can see, the lowest measurement was 27.08mm and the highest measurement was 27.12mm. The parallelism of this brake rotor when subtracting the 27.08mm value from 27.12mm is 0.04mm, which is outside the 0.015mm spec. Next, I'm going to check the rotor's runout. Basically, we're checking for the consistency of the rotor's movement from side to side as it turns. We're hoping for as little movement as possible. The hub's wheel bearings should be in working order before continuing. This is a cheap dial indicator I bought at Harbor Freight a number of years ago. I'm not sure of its accuracy, but it seems to work okay. The base of the tool has a magnet and a lever to engage and disengage the magnet. I attach the base to the strut, then set the indicator needle as perpendicular as possible to the rotor. Also, the needle is depressed a little so it can move in and out as I turn the rotor by hand. I've already turned on the indicator and pressed 0 to reset it. I then slowly turn the rotor clockwise on the passenger side, mimicking the rotation of the wheel as the car drives down the road. The precision of this indicator is to the hundredths of millimeter. It can also be set to display inch measurements. The measurement varies from negative 0.04 millimeters to positive 0.04 millimeters, or 0.08 millimeter total variation. Having found the lowest measurement, I repeated this test to confirm the variation by setting the dial indicator to 0 at the low point. It was around 0.07 millimeters total variation. The runout limit spec is 0.10 millimeters, so the rotor is within spec. So the conclusion is that both front rotors are in pretty good shape, so they could be turned to bring them back to within spec for parallelism. Some might just slap on new pads and roll with it, or replace both the rotors and the pads. But I'm going to turn the rotors to establish a smooth surface for the new pads. If you look around online, this is always a very controversial topic. As a side note, things went a bit off the rails when I attempted to remove the rotors. I just wanted to see if I could get them off. I didn't really need to remove them since I had already planned on turning them. Well, because of my curiosity, one of the screws holding the rotor onto the hub broke the tip of my impact driver's bit, and I stripped one of the other screws. I was able to remove one of the screws with a grabber extractor bit. And drill out the other screw that was practically welded in place, then retap the hole. So admittedly, this did slow me down quite a bit, but I was able to add to my problem-solving arsenal also. Messing around on Facebook Marketplace one day, I came across a Kwik-Way on-car brake lathe for $140 and made an offer of $110, which was accepted. The kit includes a motor, a frame and tool bed, vibration damper, motor belt, thin mounting nuts for situations where a standard nut won't fit, and I have an assortment of other items. It's recommended that a special Honda adapter be used to properly position the device on the hub, but I couldn't find it for sale anywhere. So I downloaded the adapter specs for $15 and attempted to make my own by recreating it in the Onshape CAD program, then printing it on my 3D printer. The plastic I used to print was very strong. The printed adapter fit perfectly, but the plastic was not strong enough to support the weight of the lathe. Carbon fiber nylon might have worked better, but I decided to scrap the idea because of the cost and the 10 hours it takes to print. I've got the pilot on jack stands in the front and the rear. I simply did that by jacking up the front first, then I jacked up the rear. You may have to go back and forth to ensure the wheels are all off the ground. Check out the videos I've made on jacking up the front and the rear of the pilot respectively if you're unsure. The front wheels are off the car and the lug nuts should be installed to 80 foot-pounds. I used some open-end lug nuts, but washers or some other type of spacer may work also. I've added a brake pad spreader in one of the old brake pads to keep the piston from being depressed. The car has been shifted into neutral by using the key to depress the safety for the shift selector on top of the steering column. Also, traction control should be turned off for cars that have that feature. The opposite wheel should be secured with a tie-down strap to keep it from moving. This is a picture of the driver's side from when I turned the rotor on the passenger side.